One of the biggest challenges in athlete monitoring is actually interpreting change. Let's say an athlete's counter movement jump eccentric peak velocity slowed by 0.5 milliseconds. Should you be worried? Is that a sign of fatigue, of reduced readiness? Or is it simply normal day-to-day variation? This is where the concept of the smallest worthwhile change, or SWC, can be really useful. In this video, I'm going to explain what smallest worthwhile change is, where the concept came from, and crucially, how we can implement it in practice using a demonstration of the Action Apps Athlete Data Management System. Much of the early work on the smallest worthwhile change is attributed to Professor Will Hopkins. And through his website, sportsci.org, he has contributed enormously to helping sports scientists interpret change in our athletes. These resources help practitioners move beyond traditional statistical thinking, like p-values, into a focus on practical significance. Rather than asking, is this statistically significant? The more useful question in applied sport is often, is this change actually meaningful? This approach formed the foundation of magnitude-based inferences, of which one idea is this concept of smallest worthwhile change. In simple terms, it represents the smallest change in a variable that would be considered practically meaningful. Because not every change in athlete data actually matters. Some changes simply reflect normal biological variation, and others perhaps measurement noise. Smallest worthwhile change is commonly calculated, particularly for physical performance measures in team sports, as 0.2 times the standard deviation of the group. That 0.2 comes from effect sizes, typically measured by Cohen's d, where 0.2 represents a small or subtle difference between two groups. So if, for example, our squad's standard deviation of, say, counter movement jump height was 5 centimeters, then the smallest worthwhile change would be 1 centimeter, 0.2 times 5. And that gives us this threshold to help distinguish between trivial change and meaningful ones. But smallest worthwhile change isn't only about determining if the change surpassed a threshold or not. We can also interpret the magnitude of the change by expressing it relative to the SWC. Instead of just saying whether a change was meaningful or not, we can actually describe it in terms of whether it was small, moderate, or large. According to Martin Bouchard, who has been a very loud proponent of this approach over the years, changes of 1 times, 3 times, 6 times, and 10 times the smallest worthwhile change can be considered as small, moderate, large, and very large, respectively. You can see that illustrated in this figure from Martin, whereby the exercise heart rate, so an individual's response to a submaximal fitness test, is plotted over time, but also these bands then of trivial, small, moderate, or large changes according to the smallest worthwhile change. This figure is taken from his absolute must-read Aspetar article entitled Want to See My Report, Coach? And I'll definitely put a link below to that publication. Clearly then, this allows us to move beyond this simple yes or no interpretation and instead actually think about the magnitude of change, which is often even more useful in applied practice. So thanks to Action Apps for allowing us to use their platform for this demonstration. And I've previously featured their platform in a number of other previous videos on this channel. We've explored their AI embedded chatbot Ava, which helps practitioners interact with their data just using normal everyday conversational language. And we also looked at their maturation tracking tool, which is designed to help youth sports teams monitor growth and maturation, which of course is key with those ages. What makes Action Apps particularly interesting and why I partner with them is because it's not just a typical athlete management system. Because the AMS applications and database is built on the Microsoft Cloud, and all the reports are pre-built and made available in Power BI, this platform allows practitioners to customize their dashboards and build visualizations internally in Power BI that reflects the metrics and the insights that actually matter most within your own team. That flexibility makes it an ideal environment for implementing concepts just like small is worthwhile change. So here in our Action Apps dashboards, then we've got a few different views. We've got our squad view. We've also got a squad visualization, which we'll take a look at, as well as then an individual view. We can see we've got our timelines here if we want to focus in on a particular date range. And we've also got our drop-down menu here for our counter movement jump metrics. As I've spoken about on numerous videos, there are of course so many metrics available for our jump data through force plates. And here in this option, we have the ability to just focus on a drop-down list that are the metrics that are part of your monitoring strategy for jumps. So here we've got our jump height calculated via the impulse momentum relationship, which is the method that I would recommend using. We've got our squad listed by their last test, and we can see not only just their result here, but how that relates to their maximum value, both absolutely and as a percentage. We've got their average, and again, that percentage of their average. And critically then here, let's focus in on this smallest worthwhile change that we've been talking about. You can see it's not just that yes or no, but we're making use of those categories according to the actual magnitude of change. So with this column then, we very quickly get a clear snapshot of the meaningful changes, but also the magnitude of change. And again, we can have a look at this for different metrics. So concentric mean force is one that I've spoken about before that I like as a profiling measure. We can see the differences there, along with, say, let's take a look at our counter movement depth, which is a metric that I like from a fatigue monitoring perspective. And again, we can see our different categories. And of course, here we have to be careful with counter movement depth because it is a negative value. How deep have they squatted down into that counter movement jump? I really like this dashboard then, where we have visualized our entire squad on this chart with their change in our selected metric compared to previous, but also then that change according to our categorization depending on the magnitude of change. We also get more information here than when we hover. So of course, these individuals here, we might focus on the most because we're seeing some decreases, in this case, small decreases in their jump height. So let's come on to our individual dashboard now then, where we can dive deeper into each player. So that's LM, we mentioned earlier, Lucy Morgan. We can see here her jump data over time. And along the top here, we have a number of contextual indicators. So we have her result from most recent result compared to the squad average, her position group average. We've got her average and maximum of her within her own data set. Of course, we can change our date ranges as well if we wanted to focus in on a particular time of the season. And how today is a percentage of those averages and those maximums. Over on this side then, we've got that change from previous and the descriptor then of the magnitude of that change according to our smallest worthwhile change categories, which we also really nicely here color-coded the data points over time. What I really like as well is whilst that smallest worthwhile change is quantifying the difference in our most recent data point to the previous, you can see here that 2 jumps ago, she set one of the highest jumps from previous, not her best, but she had a medium increase in her jump output. And so today then we've got a small decrease compared to that. But we have also incorporated here the Z-score. So that's a statistic I've spoken about before. I think it's really useful in sports science to compare the most recent data point to the entire range of her data. So pairing together then both the smallest worthwhile change, looking at today to previous, but also looking at that with the Z-score. And interestingly, plus or minus 1.5 Z-scores tends to be the threshold that I often use for flagging athletes. So here in this case, this athlete, her Z-score is less than minus 1.5. We've seen a small decrease in her output. So she's someone that I might investigate further based on their training load and other response measures like their wellness as well, just to see what's going on with her training program at the moment. If we come on to someone else, for example, then I can go here, in this case, to Ella Thompson. We can see it immediately updates on our dashboard. And with Ella then, we've got a medium increase here in her jump output. And again, combining that with the Z-score here, which is 1.58, she had a jump height greater than her average. Not quite a new maximum, but one of her higher jumps of the season, certainly. So this could be a sign that her physical development program is paying dividends. It could be a sign perhaps that she's particularly fresh. Maybe she's a substitute that isn't getting many minutes and actually could benefit from even more training, either in the gym or potentially on the pitch as well. As I've spoken about before though, of course, jump height alone is not the only metric that we'd want to look at, and we can easily then rotate through different measures here to explore some of those other physical profiling and monitoring or asymmetry measures within her jump performance. One additional concept that is important when interpreting changes in athlete monitoring data is typical error, which represents the normal measurement variability in a test, because even reliable tests will have some degree of noise. Ideally, when we interpret changes in physical performance measures, we consider both the smallest worthwhile change, which defines that smallest meaningful difference, plus the typical error, which reflects the measurement uncertainty. We can do that by calculating the coefficient of variation within our data set. Some approaches suggest that when a change exceeds smallest worthwhile change plus the typical error, we can be more confident that the change is real. This table then is again taken from Martin's paper in the Aspetar journal. And here we have an individual submaximum heart rate displayed over time, but you can see how the level of clarity and usefulness increases from left to right as we add both context and these statistical approaches. Focusing in on those final three columns, firstly, we have our changes in percentage terms, but also Excel conditional formatting of green and red has been added when that change surpasses the smallest worthwhile change. Next up, the conditional formatted has been adjusted to only show when the change is greater than the smallest worthwhile change plus the typical error. And then that final column, adding even more context, using magnitude-based inferences to display whether the changes are likely to be substantial, likely, or very likely changes. Whichever approach we take and however we then want to visualize our data, as I said earlier with action apps, we can go ahead and customize their Power BI dashboards exactly how we want them to be displayed. So the key idea is simple. Not every change in athlete monitoring data is meaningful. The smallest worthwhile change helps to define what actually matters. And platforms like action apps allow us to embed that logic and that calculation directly into our monitoring dashboards. So thanks again to Action Apps for allowing us to use their platform for the demo. And as always, if you enjoyed this video, please like and subscribe and come back again soon so you don't miss out on another Sports Science Insights video.